Continuing our chapter of area, and just kind of an extension of what we've already been doing with area is involving trigonometry. Kind of been doing that all along anyway. But now they get harder. So everything is fair game. What are area formulas? Well, we have area of a parallelogram, so base times height. We have area of a triangle, base times height divided by 2. We have area of a trapezoid, so that's B1 plus B2 times height divided by 2. We have our area of a kite, and that also includes a rhombus in it. Diagonal 1, diagonal 2, divided by 2. And then we have our area of a parallelogram, or not parallel, a polygon, regular polygon, which is AP divided by 2. Some of you on your quizzes are not using the correct formula. Some of you on your quizzes are, or in your homework also, you don't write the formula or you get stuck and you don't know where to go. You need to write the formula first. You identify the shape. You identify which formula you need to use for the area, and you write it down, and that should guide you to what steps you need to take to solve. So let's say we have this shape right here, and I give you this, say this, and let's say this. And I ask you to find the area of that shape. You, as a first step, should write down the formula for area of a triangle, because it is a triangle. Now, I don't care whether you put this little symbol next to it. I just use that to differentiate all the different area formulas. You don't need to write that symbol there. It's just a subscript. But we write down base times height. Writing down this formula is an essential step for you, because not only does it show me you know which formula you're supposed to be using, but it helps most of you to figure out what you should do next. Because this tells me what information I need. I need a base and I need a height. Now, of those things, what do I have already?
The base.
I have the base, okay? But I am missing the height. So that leads me to think, well, maybe I need one, since I don't have it. And I could draw several heights here. I could draw a height right here. Okay, I could draw a height right here. I could draw a height right here. As long as it's perpendicular to the base that I've selected. I'll draw it right here because it's convenient to do so. You draw it wherever you want, as long as it's perpendicular to your base. So there's my height. Now I need to figure out how to get this height from this shape. Well, I've essentially constructed a triangle right here, which is what comes down to any of these questions that involve trigonometry. You need a right triangle, and we have opposite. Now, do I have this side right here?
No.
No, I don't. I have the entire 17, so I'm not going to be able to use the 17 because I have no idea where this, how this is divided up. At least not yet. I could figure it out, but I don't need to figure it out. I'm going to use this hypotenuse, this side, so I have opposite and hypotenuse, so I should use sine of 40 over equals h over 6. Each question is going to be slightly different. I cannot possibly go through every possible combination of question. You have to know how to think through it yourself, which is why you write the formula, which is why we did the trigonometry. So we want to keep several decimal places here. We'll keep 3. So 6 sine 40 is
3.857.
3.857. Now, already we've done questions that involve trigonometry anyway. And okay, I put that in for B, but it doesn't, the order doesn't matter. 17, and then divide by 2. We'll multiply, and then divide by 2. And then we get what for our final answer?
32.785.
875?
What do you mean?
785.
785.
What do you mean by it's going to get harder?
Well, it's just going to, previous sections, you had some trigonometry in them. this section, trigonometry is in every question. Okay? But it's not essentially anything that is brand new.
Gotcha.
It's just the same
Okay,
stuff. Just
talking more about this triangle, and let's do another triangle going on. I want you to recognize this setup in a triangle. That way you can shortcut a little bit. So draw this triangle, and then I'm going to go back to the previous slide to get you to recognize something that will help you immensely to get these correct. At least the triangles. All right, let's go back. Notice I have this side, I have this angle, and I have this side. And notice how I got my height. 6 sine of the angle, right?
Right.
All right, let's do this one. Again, I have a base. Now I could use this as my base, but that's not going to be especially helpful because then I would need to draw a height right here, and I'm not going to be able to get any of the angles. So I do need to draw my height opposite my angle. Do you see what I mean?
Yeah.
Okay. So, how am I going to get this height?
You're gonna have to use trig.
Sine
Yeah.
48, 12.
So the height, well, sine 48 equals height over 12. Height is 12 sine 48. So, what's my height to 3 decimal places?
Do you want to round the decimal place or do you
Round.
You
over.
round up or down depending upon
Okay, then 8.918.
8.918. Okay, that will be our height, and our base is 21. So remember, the height you draw must be perpendicular to the base that you drew, and also needs to be opposite of the angle that you know. And then what's our final answer for this triangle?
93.639.
Very good. 93.639. All right, units squared, whatever units that we happen to have here. Okay, notice here, once again, in this triangle, notice my setup, side, I have an angle, and then I have a side. And how did I get my height?
12 sine 48.
Okay, and how did I get it here?
6 sine 40.
Okay, so what if I put all of this in at once? I want you to see this. So my height was 12 sine 48. What was my base in this question? This one?
21.
21. Do you notice what I end up multiplying? The side, and the angle between them. Do you see that?
Yes.
So whenever you have, so this is one of those cases like if you want to do one of them fast, if you have a side angle side set up in a triangle, you can use this formula and get your answer a little bit faster. We'll call it side 1, side 2, times the sine of the angle between them. It's still base times height divided by 2. But what I'm saying is if you want to shorten your work rather than draw it all out and do these extra steps, it's always going to end up, if you have a side angle side set up in a triangle, it's always going to end up, you multiply the two sides times the sine of the angle between them. It always ends up like that in this setup. No matter what the angle is. It doesn't matter what the angle is. It will always be that. Now, knowing this is especially helpful if, see, this is our side, and this is the angle between them. Okay? This is especially helpful if you have an obtuse triangle. So let's take a look at an obtuse triangle. Noah, you should be writing your notes. Alright, so we have 100 degrees right there, and let's say this is 16, and let's say this side right here, let's say that's 14. I have that side angle side setup. Now I'm gonna just show you why this is helpful. Like, how am I going to draw the height perpendicular to this base or this base in this triangle? Well, here's my height. I could draw that height right here. Okay, but notice that the angle's not involved at all. I would need to know this angle right here, which I could get. It's 80. All right. Why is it 80? I saw a confused look. Well, if this is 100 right here, what's this angle right here? These are supplements, aren't they? So I have 180 degrees there, subtract the 100, and I get 80 degrees. Hence, if I draw this down and I extend this side, this angle right here is 80 degrees. But I don't need to worry about that. You don't need to be confused by that because I don't need to know it. Because if I recognize that this is a triangle with a side angle side setup, to get my area, I can just use side 1, side 2, times the side of the angle between them. And then, all I have to do is pop in all these numbers. 16 is the side 1, 14 is the side 2, and the angle between them is 100 degrees. Pop that into my calculator, do all of the top, then divide by 2, and what's my answer?
110.298.
110.298 units squared. Okay. Let's do then a polygon. So we talked extensively about polygons. Any questions on this? Guys, good? Give me a thumbs up if you're good. Like that makes sense to you? You can do it? All right, do one on your own, and then we'll do a polygon. What were you saying, Noah?
Is that a formula that we'll need to know?
Yes.
If you want, okay, if you want these triangles to be easier, to have a side angle side setup, is that a formula you want to know? Yes. Okay, if you want to do it, divide it up like I did here 2 times, then by all means don't memorize that formula and divide it up, because you can do it that way. It's just longer. Okay, I was trying to help you out, but if you don't want to be helped out, that's fine.
No, I was just asking.
All right. Well,
I didn't know.
know it. Okay. So let's have a let's have an obtuse angle here. Let's have 110 degrees. Okay. Let's say this is 7. Let's say this is 9. Go ahead and give that a shot.
Give it a shot. That was not a funny joke. A lot of yesterday, Mr. Kang. Would I use a trig function, Mr. Kang?
Use that formula we just learned.
Okay.
So we recognize we have a side angle side setup.
Oh, we're sorry that.
This is why one of these days, someone in this room will be hung. It'll probably be me. Alright, area of a triangle.
Okay, quit.
A1, A2, sine of the angle between them, which is what we just went over.
Okay.
Side 1 is,
7,
side 2 is,
9,
and the angle between them is
10.
all divided by 2. What do we get for our final answer?
29.600.
Say again?
29.600.
29.6.
Mr. Kane.
Yes.
Then how come I used 70? Because I did like the right triangle thing and I still got 29.6.
Good question. What is the sine of 70? Type that into your calculator.
It's the same thing as sine 110. Because you remember, you add them together, you get 180. They're the same.
Oh, so I can do that and it still would work out every time?
Yeah.
Okay.
So
Yeah, the
sine
sines
80
and complements are the
and
same.
110 is the same.
I mean, the sine and supplements are the same.
Thank you.
Yeah, sine of 70 equals the sine of 110. Likewise, the sine of 30 would equal the sine of 150. Okay, those are the same. which is why this little formula is going to work without dividing this triangle up like this. Okay? Alright, let's go on to, let's say I have a 9-sided regular polygon. Now we've done enough of these that I'll probably just do 2 examples and call it done for our notes. We'll have a 9-sided polygon with radius.
So that means that you're gonna have a circle on the outside, correct?
Well, yeah, but I'm not going to bother drawing it.
Okay.
Okay, so nor am I going to bother drawing a 9-sided shape. Okay? I know it's a regular polygon, and I want to find the area of this polygon. So I'm just going to draw like a little section of it. Just enough that I get the general gist of what's going on. So here's a part of it. And I'll draw a center. So there's my center. And I'll go ahead and draw the radius. Now the radius would be drawn from that center to a vertex. So this is my radius. That's 12. Likewise, over here, this would be 12. Okay? Now, since this is a regular polygon, what is the formula that I need to use?
A1. Oh.
AP
Over 2.
over 2.
I see now.
Okay?
Yeah.
This is why we write our formulas first. We write our area of a polygon. Okay, I need the apothem and I need the perimeter. Do I know the apothem?
No.
No. Do I know the perimeter?
No.
No. Which, by the way, many of you in your quiz never found the perimeter. You found the side and then didn't find the perimeter. So we need the apothem and the perimeter. So I'm going to draw this right triangle here. Just like we've been doing. Okay? Now in order to solve this triangle, so I have a 12, I need the apothem, and I need this little x right here. I need to know this angle in here. Who remembers how to get that angle?
360 divided by 18. 20.
No. Just be 18.
20.
20.
It equals 20.
Yeah.
Oh.
Okay. Now, if you didn't see where they got the 18, the way I have been doing it is I divide by the number of sides. That would have given me 40. But then that 40 would have been this entire angle right here. I only need half of it, so 20. But if you want to get there right away, you can divide it by 18 instead of 9. Okay, going on. So I have a 20-degree angle in there. Set up. How can I get the apothem?
You just implant the numbers.
Opposite and hypotenuse.
Which is?
Sine.
But to get the apothem, you want a cosine.
Because adjacent hypotenuse.
I thought we should talk about that.
So it'd be
That would be
cosine
next.
20 equals A over 12. And then 12 times cosine 20 is 11.276.
Okay.
Now,
and now,
in
Emma, to
places.
find x, which is half of our side,
Use sine 20 equals x over 12.
see how I used the formula to guide what I need to do. So what's x? To the nearest, give me 3 decimal places.
So, wait.
4.104.
4.104. Now, is that p?
No.
No. Is that the side?
No.
So I need to multiply that by 2 to get the side, because I have half of the side.
yeah. So, oh, you want us to do it?
And you get 8.20.
And then to get the perimeter, I multiply that by
9.
9.
73.872.
73 point.
872.
Okay.
872.
Now we put all these in. I'll get to your question in a moment, Kevin.
So
Alright, can I erase this though?
C.
Alright, I'll erase
Si,
that.
senor.
Alright, so A was what again?
You erased it. It was 11.
11.276.
I've got the answer right here.
P was 73.872. And then divide by 2.
416.5.
416 point what?
5.
Units squared. I'll trust that you did that right.
That's
Kevin,
right.
what's your question?
See, this stuff is like, it's not hard, but it's like,
It's hard for me to remember all of these stuff. Just to
Okay, that's why you need to write this formula, and every formula that you use to guide what you do. So after we write this formula, we see we need to find A, so we use trigonometry to find A. To get the perimeter, we know that we need to know this side, so we use trigonometry once again. Okay, we'll do one more. Let's do a 10-sided polygon with,
Radius of 5.
well, let's not do a radius this time because we just
Do an
did a
opossum.
radius.
Yes, a possum of 5.
Let's do something completely different with perimeter equal to
5.
5. Really?
Yeah.
No.
Yes.
No.
50,
5.
Let's be
50.
nicer. Let's do
50.
50. If you want to do a lot of decimals, we'll
I was thinking about WREO whenever I said 5. So.
Okay, so, anyways, I'm not going to draw a 10-sided polygon. I'll just do a little section of it. Now, I write my formula.
Okay.
Formula for a polygon is AP divided by 2. This time I know P, but what am I missing?
The opossum.
The apothem. So I'm going to draw my center, and I'll draw the apothem. Remember, the apothem goes from the center directly perpendicular to one of the sides, and I'll complete this triangle right here.
The bottom part from the right triangle sign to the point would be 25, correct?
Well, hold on. This is A.
Right.
Now I need my angle in here. How am I going to get that angle?
360 divided by 10.
Divided by
20.
20 or 10, then divided by 2, whichever. And in the end, what do we get for that?
18.
Okay, so this is an 18-degree angle in here.
Right.
All right, now the question is, I don't have any of these sides right now. But in order to do this triangle, I can get this one right here.
25.
It's not 25.
Why?
I gave you the perimeter. So the perimeter would be all the sides add up to 50, which means I need to take that 50 and divide it by.
10, 5.
So that gives me 5.
Then divide that by 2.
Then I divide that by 2 to get this part right here, which is 2.5.
Wow.
So now I have opposite and
Adjacent.
so tangent of 18 equals 2.5 over A. Cross multiply or clear, whichever way you want to think of that. And then we divide both sides by tan 18. So 2.5 divided by tan 18.
7.694.
Okay, so now we have our apothem, so we can go back to our formula. And the area of the polygon is going to be 7.694 times
50.
50 divided by 2.
192.4.
192.
192.4.
In sync.
Yeah. Let's skip.